So after understanding the finite state machine representation of a TCP and also its timeline diagram, now we'll move on to the next concept of windows in TCP. So we had discussed this. These windows are nothing but buffers. So TCP uses two windows for each direction of data transfer. Let's say there is a client and a server. So here we'll have communication from client to the server in one direction and from server to the client in another direction. Okay. So in each direction there will be two windows. There will be a send window and a receive window. Okay, for one direction from client to server. Similarly, there will be a send window and a receive window for the opposite direction communication. There will be a send window at the server and a receive window at the client. Okay, so therefore there will be four windows for the bidirectional communication, and we already know that this TCP offers full duplex communication between the server and the client. However, to understand the concept of windows in a simple manner, what we do is we make an assumption. Okay, however, this assumption is unrealistic. Okay, it doesn't happen in the real world. So we make a simple assumption that the communication is only unidirectional. Okay, so this we are making just for the sake of reducing the complexity of understanding. Okay, and we'll assume that this communication is happening only from client to the server. Okay, so once you understand this, you can later extend this to bidirectional communication uh, by using two unidirectional communications. Okay, so by two unidirectional communications we mean one from client to the server and another from server to the client. In addition to this, we will also use the concept of piggybacking. Why do we require piggybacking? So whenever the participating entity is sending a data in one direction, it can also send acknowledgements for the packets that it has received in the opposite direction. So a combination of two unidirectional communications along with piggybacking will make us understand the bidirectional communication with Windows. Okay, so let's try to look at these two types of windows. So if you look in the diagram, we have a send window which is a buffer. Okay, a temporary memory allocated, and let's assume that the size of this buffer is 100 bytes. Okay, so if you look at the diagram here, so this is at the sender, and if you look here, the size of the send window will not be the same. Okay, it can open towards the right, or it can close from the left, or sometimes shrink also. Okay, and all of this could be because of the congestion, and this send window size usually will be dictated by the receiver. Okay, so if the receiver cannot read data in a very fast manner, then he says that reduce the rate at which data is being sent, in which case I have to reduce my send buffer. That is what we mean by shrinking the send window. So if you look at the diagram here, okay, so the black colored section is the buffer, and this is also called as the send window. And this again among the send window, so you see certain bytes prior to the first outstanding byte 201. Okay, so these bytes have been returned to the buffer, and you have also received acknowledgement for them. So acknowledgement says that this data whatever was sent has been successfully delivered. So these bytes that are acknowledged can be now actually deleted or purged from the buffer so that it could be reused later. So now the data that is yet to be acknowledged, okay, you cannot remove it from the buffer. It has to wait till you get an acknowledgement. Okay, so here in the buffer you see certain blue shaded section. So this blue shaded section is the data that has been written to the send window, and it has been sent to the receiver, but the receiver has not acknowledged it yet. Okay, even though it has been put on the communication channel, you cannot delete it because they are not been acknowledged. So that's the bytes, for example, ranging from 201 up till 260. Okay, so the first outstanding byte we'll represent it as SF. Okay, and the bytes that can be sent, okay, that are still not sent, are part of the usable window. What we say that, okay, the application has written certain bytes into this section, they are not sent yet. Okay, so this portions refer to what is called as the usable window, which is nothing but the bytes that can be sent, that can be put on the communication channel. So the first such byte to be sent is called as SN. Okay, and on the right side, okay, 300 is the buffer limit right now. Okay, you can't write anything beyond 300. So bytes that cannot be sent until the write edge moves to the right. So if the application is the sending application is writing to the send window, it can write bytes up till 300. Okay, when it has written till 300, it means that the buffer is full or the send window is full. So after 300, it is the bytes that cannot be sent. But is it the case that it will remain forever? No. Let's say that from some of the outstanding bytes, okay, the blue shaded ones, let's say that the first 10 bytes we have received the acknowledgement. In that case, okay, the left sided arrow here will move advance by 10 bytes, and as a result of which, okay, because this is a circular buffer, the right side limit can also be increased by 10 bytes. Okay, so that is what we say on the right side, bytes that cannot be sent until the write edge moves to the right. Okay, and you can also see the left wall keeps closing. It can move only in the right direction. As it starts getting acknowledgement, the data need not be maintained in the buffer. So as to remove it, we keep moving the left wall to the right direction. That is what we mean by closing the send window. And at the same time, as a result of which, okay, the left wall is keep closing because of the vacancy being created by the acknowledged bytes. The right wall can open, okay, can move to the right direction. That is pretty obvious because vacancy has been created. You can now add more bytes at the right end, but at sometimes this right wall can move even in the leftward direction. That is when shrinking can happen. Okay, when does this happen? So this might happen when it receives a feedback from the other party saying that you are sending me at a very higher rate. I cannot handle that much amount of data. So reduce the rate at which you are going to send. So how does the sender respond to this? The sender responds by reducing the size of the send window. Okay, that is the point when the right wall shrinks in the leftward direction. Okay, and when we talk about TCP send window, we need to compare it with the selective repeat protocol. Okay, so this selective repeat protocol and go back n are there in the chapter prior to TCP. Okay, anyway, that's not part of the syllabus, but still, if you bring about the comparison, even there we have a concept of send window and receive window. The difference is how the size is measured. Okay, so in TCP we measure the size of the window in terms of the number of bytes. Okay, so in the diagram that you see below, the size of the TCP window, the send window is 100 bytes because it spans from 201 to 300. However, in selective repeat protocol, the size of the TCP, the size of the send window will be measured in number of packets. Okay, so in TCP we measure it in number of bytes, whereas in selective repeat we measure it in the number of packets. And also another difference is in the way these are implemented. In TCP, the sending TCP is capable of sending segments of data as soon as it receives them from its process. Okay, so once an application process at the sender writes some data to the sending TCP, the sending TCP doesn't buffer them, rather it is capable of sending these data as and when it has received. Another difference between the send window implementations of TCP and selective repeat SR is the number of timers. In the SR, in the selective repeat, this process can use several timers, whereas TCP uses only one timer. Okay, that will be discussed later at the end of the chapter. On the other hand, we also have a receive window at the receiver process. Okay, here also looking at the diagram, you can see that the size of the buffer is 100 bytes from 201 to 300, and this receive window can open and close. Okay, by closing, the left window moves to the right, by opening, the right window moves to the right. Okay, however, in actual practice the receive window should not shrink. Okay, it is clearly determined by the receiver, and this is not going to change. Okay, what is going to change is the sender's window. Based on the feedback from the receiver, the sender might have to reduce his window size, because of which the send window could be shrink, whereas the receive window, there is no need for shrinking it because it is fixed. Okay, that is dependent on the client's capability, the receiver's capability. If the receiver says I can receive a maximum of 100 bytes, okay, then in any situation, this receive bytes, the receive window size will be 100 bytes. Okay, so let's look at the diagram and try to understand slightly more. So if we look at the diagram here, up till number 200, these are the bytes that have been already pulled by the process. So imagine now, what you have to imagine is the TCP at the receiver, which in turn connects to the application at the application layer. Okay, so the application is continuously receiving information from the TCP, and because the application might be reading slowly, we will have a receive window. So all the bytes that have been already read by the process are the bytes shown in white. Okay, prior to 201, these are the bytes that are already read from the application. Okay, at the application process, at the application layer. And the rest of the process, the rest of the data, okay, are the bytes that have been received and they have been acknowledged also. Okay, the sending process has been informed that these bytes have been received successfully. That is what we mean by bytes are received and acknowledged. But it doesn't mean that if you have sent an acknowledgement you have to delete the data from the receive window. Okay, we do that in the send window. When you get to know that a particular byte has been delivered successfully on the sender side, then it is going to delete that byte. However, in the receive window, there could be certain bytes that have been received from the sender and they have been successfully acknowledged also, but they are yet to be consumed by the process. So such contents should remain within the buffer. So data from 201 to 260, they are waiting for the application to read this particular data. Then the amount of buffer left, 261 to 300, this is the space where newer data received from the sender can be placed. Okay, so from 261 to 300 it represents the bytes that can be still received from the sender, and this particular size, okay, which specifies how many bytes can be received from a sender, is called as the receive window. Okay, even though in this case the size of the buffer allocated is 100 bytes, the receive window size is just 40 bytes because 201 to 260 is already occupied by bytes that are waiting to be consumed by the application process. Okay, so this is with regard to the receive window. Again, if we compare the receive window with that of the selective repeat, the differences is that the TCP allows the receiving process to pull data at its own pace. Okay, if the application is slow to read the data, then the contents will be stored in the receive window, which also means that some part of the allocated buffer at the receiver will have certain bytes that have been received and acknowledged. You have already said that yes, I have received this data, but still they cannot be removed from the buffer because they are still being waiting to be consumed by the receiving process. So therefore, as discussed earlier, okay, how do we calculate the size of the receive window? The receive window is represented as RWND, which is equal to the total buffer size minus number of waiting bytes to be pulled. Okay, so in our case, in the previous case, the number of bytes that are waiting to be pulled is from 201 to 260, so which is 260 bytes. The total size is 100, so the receive window size is 100 minus 60, which is 40 bytes. Okay, so this particular 40 bytes we call it as the receive window size. Okay, so now this can give a feedback to the sender saying that currently my receive window size is 40 bytes. Okay, don't send data that is much larger than 40 bytes, that I can, otherwise I cannot hold those particular data. Another difference between the TCP as a receive window and the receive window in the selective repeat is the way acknowledgements are being used. In selective repeat, the acknowledgements are selective, like every fifth packet will be, or every fifth segment we will send an acknowledgement. Whereas in case of TCP it is cumulative. So if I send a acknowledgement for bytes 250, then it is saying that I have received all the bytes up till 250. That's what we mean by cumulative. Okay, so these are how the windows are used at the sender and the receiver, and again another pair in the opposite direction. Okay, so with receive window it can only close or open, it cannot shrink. Okay, whereas the send window can shrink based on the feedback received from the receiver.